The table shows the population of Nepal in millions as of June 30th of the given year. Use a linear approximation to estimate the population at mid-year in 1989, and then use another linear approximation to predict the population in 2010. So the first part is to use a linear approximation to estimate the population at mid-year in 1989. So we're going to call this part A. And so for part A, step number 1, we want to write down our linear approximation formula. So L of t is going to equal n. Now we're going to use 1990 because if we want 1989, we're going to choose that year that's going to be close to 1990. So therefore, A is going to be 1990, so it's going to be n of 1990 plus n prime of 1990 times t minus 1990. Okay, now what we want to do is, since we want to be able to find n prime of 1990, that means we're going to have to find the rate of change between 1985 and 1990. So we want to find the rate of change between those two years. Okay, so we're going to let that, we're going to call it A. Okay, so that means we're going to take n of 1990 and then subtract n of 1985 and then divide that by 1990 minus 1985. So if we put those numbers in, we get 19.33 minus 17.04 over 5. And so what we get is 0.58. And that's millions per year. So that's the rate of change for those two values. Okay, then we want to be able to find the rate of change between 1990 and 1995. And the reason why we do that is then we can find the average of those two to give us an estimate of what the slope would be for 1990. So we're going to let B then equal n of 1995 minus n of 1990. And so therefore, using the information from the table, we know the output for 1995 is 21.91 minus 19.33, and divide that by 5. And so we end up getting 0.516, and that's million per year. Okay, so now what we can do is in step 3, in order to find n prime of 1990, we can take the average of these two slopes. So we can take A plus B and then divide that by 2. So if we take 0.458 and then add 0.516 and then divide that by 2, then we get 0.487 million per year. So therefore, there's our slope. So now we can plug it now into equation number 1 if we want to be able to find the approximation population at mid-year in 1989. So we're going to find L of 1989, and then we're going to plug it into our formula in step 1. We know that n of 1990, the output is going to be 19.33. And that's going to be plus, we know that n prime of 1990 we found to be 0.487. Now we're going to multiply this by 1989 minus 1990. And so when we plug that in, we're going to get 18.843 million. So that is the population, or the estimate of the population for 1989. Okay, now in part B, for the last part, it's asking us to use another linear approximation to predict the population in 2010. So in order for us to do that, okay, if it's 2010, then we're going to have to use the year 2005, which is what's given for us. So we're going to have to find the rate of change between those two points. Okay, which means that we're going to use 2005 as our A in our linear approximation. So L of t is going to equal n times 2005 plus n prime of 2005 times t minus 2005. So we want to do is, since this is step 1, step 2, we want to find n prime of 2005. So in order to do that, we're going to take n of 2005, subtract n of 2000, and then divide that by 2005 minus 2000. So we have 27.68 minus 24.70 over 5. And that's going to give us a rate of change of 0.596, and that's million per year. And so now in step 3, we can now rewrite step 1 to be L of 2010, and that's going to equal n of 2005, which we know the output is 27.68. Plus we know n prime of 2005 is 0.596. And we're going to multiply that by 2010 minus 2005. And so we end up getting 30.66 million as the prediction of the population in 2010.